Hope you're doing very well. So today we're gonna see why a quicksort algorithm is known as divide and conquer algorithm. What are the various terminologies used in quicksort and what are the steps? So let's get started. First, let us see two main things. First is pivot. Pivot by English we know it is a central point around which any objects or anything rotates. So here in array we will consider any element as a pivotal element. So either we could choose, generally people can choose last element, first element or middle element, but it totally depends on you. You can choose any element as a pivot element. Now second part is what is partitions. So partitions are nothing just a part of array. They can be a sub part of array. You can also say it is sub array. So partitions in this quicksort are generally formed after choosing pivot and rearranging the elements of the array such that the elements on the left side are smaller than the pivot element and on the right side are greater than the pivot element. For example, here you can see we have not done any partitioning, any rotation of the elements. We have just chosen pivot, which is 50 here. And now we will do some rotation in the array. We will see how we're gonna do. There are multiple algorithms through which you can do the rotation of algorithm of the array. So first let us see how our array will look like after we do the rotation. So here we have considered these are the elements of the array and we have chosen last element as the pivot element. So 50 is the pivot element and according to 50 we have put 50 into correct position, which means that we have found an index after which the elements are greater than the pivot element and before which elements are the smaller than the pivot element. So the key steps of quicksort algorithm are basically two things. One is you find a pivot element and second thing you do the partitions. By partitions we mean the rearranging of the values also. So I have written one such algorithm in Java. We will first see the Java version of quicksort algorithm and then we will go for Scala version. You will be very surprised to see that in Scala we do quicksort in just 5 to 6 lines hardly. But let us first cover the sorting algorithm in Java. So we will mainly focus here in the partition functions. So what partition function will receive the input? Here we are considering that we will always choose last element of the array as the pivot element. So the input of partition function is array, low index and the pivot index. Pivot index is also the high index. You can say these are the boundaries. What is the range of the array that we have to partition? So low to pivotal index or highest index is the part of the array which we have to partition. So now how we gonna rearrange the elements? For this we have just written one simple loop and again some swapping part. We will see this. So first we create an iterator. We can say this is left last index. This left last index green color arrow signifies that before this and up to this point all elements are smaller than the pivot element, but at the starting it should be a low -1. So 0 -1 will be -1. It means there are no elements which we have considered that these elements are smaller than the pivot element, so that's why we keep them as -1. Now we create one loop from low to high index or pivot index. In this in this loop, we check each and every element with pivot element. What we are doing is we are comparing the array of index position. This blue color is index iterator and this green color is left last index iterator or index, whatever you can say. So this index is at 0th position. So we are iterating from 0th position less than the length of the array. Basically we are not iterating up to the last index. So the basic condition is if we found any element in the array which is smaller than the pivot element, we will replace it with the left last indicator position, but left last indicator first should be incremented. So also let us do one iteration and you will understand very clearly. Suppose in the starting position our index is at 0th position. Okay, we compare this 20 with 50. So 20 is smaller than 50. This condition satisfies. We increment the left last indicator. So this green indicator will come to 0. Right? Now both indicators are pointing to 0 and we have to swap the elements. This creating temp variable is a very generic thing. This we are storing the temporary variable in temp variable array of index, and then we are swapping it with the left last indicator index. So 20 will replace with its own position. Same way, if we move to next iteration, we will move this index iterator to first position. Now we will compare 10 with 50. Yes, 10 is also smaller than 50. So again we will increment the left last indicator to one more position, rightwards, and then we replace 10 by 10 on place, which means no change in the elements of the array. Then we will compare 90 with 50. Now here 90 is greater than 50, so we will not do any interchange of the positions of any elements. We will simply increase the iterator from second to third. Now we will compare 80 to 50. Again, this condition is not satisfied, so we will again move the our index iterator to fourth position. In fourth position, same 70 is greater than 50, so pivot element is actually smaller than the array of index element, so we will do nothing. We will simply move the iterator to fifth position. So at fifth position, same condition satisfies. We do not find any element which is smaller than the pivot element up to this point, and at this point our loop will ends. After this, we have to swap the element of which index the left last indicator plus one position, which is 90, will get replaced or interchanged with 50, which is at sixth position. So we will just increment it. I'm sorry, we'll just increment it. This is going to be the iterator at line this line, left index plus 1, and we will interchange 90 with 50. So after interchanging, our array will look like this. Okay, so one thing is confirmed after this partition function. One thing is confirmed, that uh, we can definitely say that when the left array and the right sub array are sorted, if you sort this left sub array 20 to 10 and the right sub array from third to sixth index, if this part is sorted, 50 will always be at its correct position, because we have rearranged the values accordingly. So this way we can say this these are basically the steps of the algorithm to sort the array. So first we will find the pivot element, then we will do the partitions. In partition we will rearrange the values, and hence we will recursively do the same things, and we will get the sorted array. Now let us see how we will implement this. So let us cover the implementation part. First, let us create new project. So here I will be using Scala as the language, and SPT is going to be the build tool. I'm clicking on next. Click on next simply. Waiting. Now let us name it as quick sort function. Package prefix would be com.github.msr. Check this box. Finish. We can close this old project. Okay, we move on to src main folder. Within main folder we will create another directory for Java codes. In Java we can create a class known as quick sort in Java. Okay, so after this we will create main function. Let us define the main function. The static void main. We create an array of integers with some random numbers, 11 to 167, 7, 66, 12. Okay, now we are going to create a sort functions in which we will pass array, the low index, the highest index, which is array length -1, and after this our array should be sorted. So first let us define this sort function. Okay, let us rename some values here. So the input would be arr array, int I would be the starting position, so we can name it as low index. I1 will be changed to high index. then we will write if low is less than high, because we only need to come inside this block of code if low is really low is less than high. Otherwise there will only be one element and we don't need to sort it. So that's why we are putting this condition. Next we find the pivot index. So pivot index will come out with partition function, and partition function will pass array, the low index, the high index. Okay, let us correct the typo. Pivot, pivot index. Once we find the pivot index, we will sort the left array. So we have to pass from low to pivot index -1, and we have to sort the right subarray or the right partitions, which is pivot index +1 to highest index. Okay, so now comes the partition part. Partition part will be same as we have seen the implementation in explanation. Same I am just implementing here, just few renaming parts. I will rename this high index as pivot index, because in this sort function we will always choose the last element as the pivot element. So first we will store this pivot element in some variable. Okay, next part is we have to create a left last indicator which will point actually the low -1 initially. Now we have to create a loop starting from low, and it should go up to pivot index less than pivot index, and in each iteration we will compare the index position element with pivot element. If the pivot element is greater than index position element, we will increment the left last indicator and swap and do the swapping part. So for this I'm just creating a temporary variable storing index position element in temp variable, and in index position we can store the left last indicator, index indicator position. Next we can store the value of temporary variable in left last indicator position. Now once this loop is finished, we just have to do the final swapping part as we have discussed. So I will just quickly write it down. Pivot index pivot index is equal to array of left last indicator +1 left last indicator +1 equal to n. And now comes the returning part. We have to return the index of pivot element also. So in our case it would be left last indicator plus first position. So this way our partition function is also completed. So now you can see we have already completed the quick sort algorithm. So let us create one more function to print the array of the functions. Print array will pass simple the array, and let us implement this print array function also. So for ith position 0 to length I plus, we will just print the element of ith position and leave some space for distinction. Okay, so now let us run and see what is the output. Yeah, so as you can see 1 2 7 11 12 66 and 67, these all elements are in order, ascending order. So this way you can implement the quicksort algorithm in Java. Now let us move to the Scala part. So in Scala we can first create an object, any object. Let us name it as quicksort. We will extend it with application so that we can run the functions. Now we will write the function of quicksort algorithm. Quicksort, it will take input which is of type list of int, and it will also return the list of integers. It should be sorted one. Now we will use match case for implementing the code. So we will match input with few cases. If it is nil, here nil means the empty list. The list is empty, it does not contain any element, so it is nil. In case of nil, we just simply return the empty list. But if the list is able to split into head and tail part could also be empty, but if we are able to split the list in head and tail part, it means it will have either one element or more than one element. We will store two separate lists, which we can say low and high. This low and high will have the values of list partitioned by the head element. So as in Java, when we have implemented, we have chosen the last element as the pivot element. But in this the implementation, we are choosing head element as the pivot element. So we are comparing the every element of this tail with the head. If it is smaller than the head element, any arbitrary element is smaller than the head element, it will go to the low list. This low is a variable, it would be a type of list of int, you can see here. And any element which is greater than the head element will go to this high variable, it is a list of it. So once we got the partition list, we can again call this quicksort function on these two lists separately. Now we have to append the values of the list with variable and then variable to list quicksort high. Okay, so here we are appending this values head value after this the list, which is going to be written of quicksort low, and we use triple colon functions to do this, and two colon, we will use two colon if we have to prepend the any element to the list. So this is the way of Scala. In these 3 to 4 lines, I think the function is completed, nothing left. So let us test it quickly. We will create a println, we will write println pass quicksort function. In this we can pass some random values, 6, 9, maybe 23, 1, 2, 8. Now let us see what is the output of this function. It gives us 1, 2, 6, 8, 9, 8, 9, 23. Yeah, so this list is sorted. So in this way you can implement quicksort algorithm in both Scala and Java. Please hit the like button if you really like this video. Subscribe the channel, it gives us a lot of motivation. Till then, see you, bye, take care. We'll see you in the next video with some amazing content. Thank you.